Hello, everyone. Welcome to our last program of Thursday Astronomy Days. I'm Carrie, and I am an educator at the museum and your host today. We are very excited that you are joining us today. And I just realized that I am on my last slide of my tutorial. So let me go ahead and get to my first slide. Before we get going, we have an icebreaker question for you. And this is a tricksy one. So it's a trivia icebreaker question. So maybe you'll know, maybe not, but how many missions have flown from Earth to Mars? And so this includes rovers, landers, orbiters, and flybys. So if you have a guess, put that in the chat. And then while you're doing that, I'm going to go through and do a quick Zoom tutorial. So today we will have live captions, hopefully. And if you need to use the captions, click down at the bottom of your screen where it says closed captions and click show subtitle. And then the captions are going to look like that. To make sure that our videos aren't obscuring the presentation, you go up at the top of your screen and click view options and click side-by-side mode. That just moves our video over so that the slide is not obscured. Lastly, we love it when you talk to us in the chat. So ask your questions, make your comments, but please remember to be kind and respectful to everyone, and please keep it on topic. With that, I'm going to introduce our speaker tonight, who's going to tell us all about the really exciting history of Mars exploration. So Mike Keefe is a NASA JPL Solar System Ambassador. He is also with the Raleigh Astronomy Club. And Mike is another one of these folks who have been doing astronomy days as long as I have. So a really long time. So his help in planning and expertise has been integral to this event for many, many, many years. So Mike, welcome, and thank you so much for being here tonight.
Thank you, Carrie. Thanks to the museum. This is just a phenomenal event. I mean, it's really a highlight of the year for a lot of us in this space, the NASA JPL Solar System Ambassadors, the Raleigh Astronomy Club. So this is really where we get to share our passion with the public. So it's an amazing opportunity, and thank you for letting us do that.
Well, we have got a lot of answers in the chat. So
yes,
I'm just
we do.
17, 12, 18, 100, 40, 23, 30,
exactly.
10, 50, 79, 1,000, 165. Ethan says a lot.
Yes, yes. That's a really good question. And we'll preface it by saying that, and that includes pretty much anything that we attempted to launch. So sometimes things don't go the way we planned. So basically, the answer to that question is 70. Nope, I'm reading that backwards. 47. So there have been 47 different missions. Now,
anybody guess 47?
I saw 45.
Oh yeah, Sean said 45. Oh, you might be the closest, Sean.
Yeah, and it's not just NASA. It was the Soviet Union. It's the Russian Federation. It's the European Space Union. We've got India, and even the United Arab. I can't even speak now. The United Arab Emirates. So it's not just NASA. So it's quite impressive. So I love this picture. It just shows all the different rovers. If anyone is interested in trying to get a bigger version of that, just go to the Planetary Society and you'll be able to find that. There's a big, huge, super high res version of this picture. So now we'll get started with.
I love it.
Yeah. With actually the mission. So we've only been exploring Mars for a relatively short amount of time. We started back in the 1960s, and then when I say we, it's we as a society. So in 1960 and 1962, you had the Soviet Union. They sent 5 missions in total in that time frame, and unfortunately, all 5 failed. The first 2 were basically launch failures. They didn't even achieve Earth orbit. They were all supposed to be, or the first 4 were supposed to be flybys, and you'll see that there's a little F in brackets that denotes that was a flyby. The 5th one was supposed to be a lander. Unfortunately, that 5th one never left low Earth orbit. And we actually had Mars 1, it was a flyby, actually got close, but they lost communications before the actual flyby. So even up till then, the first 5 attempts were not successful. And then we go to 1964, where we had Mariner 3. That was a flyby. And in that case, the payload fairing, so that's the part of the rocket that covers the spacecraft, that failed to separate. And so that was not successful. But then in 1964, we had Mariner 4, and that was the first successful flyby that was sent by the United States. And that is an actual picture of what they saw from that flyby. So not very high resolution photographs that we were able to take back in 1964. And then we had some continual attempts, again, by the Russian or by the Soviet Union. Zond 2, unfortunately, they lost communications before the flyby, so they weren't able to take any pictures or see any information. We had a few successful missions next with Mariner 6, doing another flyby. At this point, the Soviet Union is not doing very well. They've had another failure. In this case, the rocket again failed to achieve orbit. We've got the Mariner 7. For some reason, my little slides aren't advancing here. That was successful. And another failure. Again, failed to leave Earth orbit. Then in 71, NASA sent the Mariner 8, and that was supposed to be an orbiter. So up until this point, the only successful piece has been anything that was flying by. Orbiter, Mariner 8 did not make it. And again, with Mariner 8, that one, again, failed to achieve low Earth orbit. The next was a Cosmo mission, an orbiter. That, again, never left low Earth orbit. And then we had Mars 2. So that was going to be an orbiter and a lander. So, and we had Mars 3, again, from the Soviet Union. That was going to be an orbiter, a lander, and a rover. And also Mariner 9, orbiter. Now, the funny thing is, Mariner 9 is at the very bottom there. That was the last to launch, but the first to actually get to Mars and orbit and achieve orbit. And Mariner 9 entered Mars orbit 13 days before Mars 2 from the Soviet Union. Now, their orbiter was successful. Their lander, however, not so much. So it failed basically to enter Mars's atmosphere. Then Mars 3, again, it orbited. They actually claim as the first successful landing on Mars. Again, at this point, the US has not landed anything. However, their lander, they call it a soft landing. Don't know how soft it was. It actually lost, they lost signal with it 110 seconds after landing, and only 70 lines of data were actually sent. So 70 lines, not 70 lines of data, 70 lines of a photograph shows a partial photograph that was sent. So again, successful, it definitely landed, but we didn't get a full image. Then you had Mars 4, an orbiter, that failed, unfortunately. It did not do the proper orbital insertion around Mars. Mars 5, it attained orbit around Mars, but lost contact after about 9 days and only returned 180 frames of data. And then we had a flyby and a lander, Mars 6. Unfortunately, that was a successful flyby, but the lander, they lost contact really as it started to make insertion in the atmosphere. And let's see, then we go to Mars 7, and my slides aren't advancing for some reason. Sorry about that. Okay, Mars 7. In this case, it was another flyby and lander, and unfortunately, the lander separated too early from the space vehicle and never was able to actually enter the Mars atmosphere. So up until this point, we've had one successful orbiter, or actually several successful orbiters, but only one partial lander. And then we get to the next stage in 1975. And this is when we sent the pair of Viking rovers. So they landed, and Viking 1 was able to operate for 2,245 sols, or that's a Martian day, which is a little bit longer than an Earth day. And Viking 2 operated successfully for 1,281 days. Now, that's a lot of time. Now, I want you to remember this number, 2,245. It's going to come up again in just a little bit. But these operated for a super long time. And now we jump all the way to 1988. So we went from 1975. You saw all those missions going in the 60s and the 70s, almost on that 2-year interval where you have basically the resonance between the Earth orbit and the Mars orbit makes it, an ideal time to be able to send spacecraft there. But really nothing in the late 70s and early 80s. And then we had the series of Phobos 1 and Phobos 2 spacecraft that the Soviets launched. And these were intended to the Martian moon, Phobos. Phobos 1, unfortunately, lost communication before reaching Mars. Phobos 2 actually was successful. It orbited Phobos, and unfortunately, the spacecraft lost communications before landing. So again, no landers on the Martian moon. Then we sent on the U.S. I mean, when you think about it, we went almost 20 years without sending anything. And unfortunately, the Mars observer lost communication before it was able to actually achieve the orbit insertion. So that was a failure. And then we jumped to 1996. And I'm sorry, why? I just had some technical problems here. Our Mars Global Surveyor. So that operated for 7 years, mapping Mars for us. And then later in 1996, we had the first Mars mission from now the Russian Federation. It's supposed to be a orbiter, lander, and what they call a penetrator. So it's supposed to jump in, or actually, kind of send probes into the Martian surface. Unfortunately, that never even left low Earth orbit. So launching rockets is hard stuff. But then in 96, we had something called Pathfinder Sojourner. And that was the first rover to ever operate on any other planet. And this was especially near and dear to my heart. I had just graduated college, and I was working at my first job, granted in a different industry, but it was amazing to see this and on live pictures. And up until this point, I was too young to see the moon landings, but this was just so amazing that we landed on another planet and we were getting as near live footage as possible of these pictures coming back, and it was just absolutely amazing. So it was launched in late 96. It landed on July 4th in 97. And it really was just a proof of concept. There wasn't a lot of science that this was supposed to accomplish. It was really to show that doing low-cost spacecraft with frequent launches is going to be a whole lot cheaper and better. In fact, this mission cost 12 and a half times cheaper than the Viking missions back in the 70s. And it actually did return some science regarding soil, geologic processes, magnetic properties, and atmospheric data. So it did actually, at the end, return some really good science. And the little rover was called Sojourner. It's about the size of a microwave. And they named the actual lander, the Carl Sagan Memorial Station, but that was called Pathfinder. And here is a brief snippet of what the landing was, the animation would look like. Inflatable balloons. Very happy for a landing. There's some real footage. I just remember at work, literally just going to the NASA and the JPL pages and just constantly saying, okay, what did they get next? What did they get next? And it was just a really, really amazing time for the exploration. And what I loved about it is they started naming all these little rocks and all these little features that they found after cartoon characters. So you'll see, Yogi Bear, and there's Scooby Doo and so forth. The actual mission was only planned for 1 month for Pathfinder. So that was the actual lander, and only 1 week for Sojourner. But they both lasted 3 months. Now, the little rover traveled over 100 meters. However, they never traveled more than 12 meters from the lander. So it really didn't move around much. So yes, and I see in the comments, Scooby-Doo was one of the rocks. I don't think it's pictured above, but yeah, it was in there. So it was pretty amazing. And again, we mentioned the key science, but what they found is the fact that, hey, we've got rounded pebbles here at the landing site. This really suggested that water had flowed during a warmer past that Mars had, and that a lot of the airborne dust was actually magnetic, and that basically happens during an active water cycle, and most likely that rust that they see has been leached out from the rocks. That iron had been leached from the materials in the crust. So again, this demonstration mission actually turned out to provide some real science. So then we go from Sojourner, and we jump over next to the first Japanese mission. Unfortunately, that was a failure. It did perform a flyby, but for some reason they lost contact due to loss of fuel. And then you have what I think is probably one of the probably most hard to swallow disasters, and that was the Mars Climate Orbiter. So the spacecraft did fail trying to attain orbit, and they believe that it burned up. And the reason was that the suppliers, so the people that built that, actually used different measurement standards. So you had one contractor using metric units, and the other one used standard measurements. So again, very, very frustrating to have that happen. Had that not been there, we would have had that basically that orbiter there. And then we also had.
Can I ask a question? Because I'm just curious.
Sure.
So what does NASA use now? Is it
metric.
more? Are we more consistent?
Everything is metric.
Is it? I figured you have a disaster like that, and they're like, okay, at least NASA's going to metric. Maybe not all of the U.S.
Well, and pretty much now the military does it, and most science is done in the metric scale anyways. It's easier to share data. So, and then we had the Mars Polar Lander, and that again. Originally, they didn't know what that was. That was going to be, again, a lander and a penetrator. But they have since found wreckage, and that's thanks to some of the other orbiters that were launched later. They've found evidence of wreckage. So then we jump in 2002. We have Mars Odyssey. That was an orbiter. By the way, that is still operational. And then you have the European Union their mission, Mars Express, was an orbiter and a lander. The orbiter actually is still operational, and Beagle 2 was the lander. Unfortunately, they never got confirmation. Now, what they were able to get from some of the other orbiters around Mars that have just amazing resolution compared to some of the pictures we showed, especially if you think about some of the first Mariner missions. But they were able to actually snap pictures of Beagle 2, and it landed no problem. Unfortunately, the solar panels never deployed, and the solar panels were basically covering up the antenna. So the basically it could never communicate with the orbiters and never send out any information. And obviously, it never deployed solar panels, so it was never able to get any energy. So unfortunately, it did land, just did not deploy solar panels. And then we have the amazing twin rovers. Such an amazing story. And when you look at that, we've got these two rovers that landed on opposite sides of Mars. They were identical in every way. And you've got Spirit. So here are the mission numbers for Spirit on the left-hand side, and you've got Opportunity on the right-hand side. And these guys were meant to last 90 days. Again, 90 days, that's what JPL/NASA was promised, and that's how long they're guaranteed to run. They ran 6 years and 14 plus in respectively. Now you've got 4.8 miles traveled by Spirit, 28 miles by Opportunity, and then there's a significant piece here on exactly how much they were able to traverse in terms of the grades on Mars. Now, what these missions were able to prove was that ancient Mars had just an immense amount of water, and the conditions were actually good for supporting microbial life. So you have these areas that they now know were basically just soaked in salty water. So this was a picture of Opportunity. They were able to find this material called hematite, and that typically forms, as we know, in water. And of course, we know water is absolutely key to life. We also know, in this case, Spirit found rocks that were 10 times richer in these key chemicals of magnesium and iron carbonates. These rocks formed when Mars was absolutely wet and warm, not dry and cold, as we know Mars is today. We found that there were steamy hot springs in ancient Mars, and we only found that when it was Spirit. One of its wheels was no longer turning, and it was just dragging, and it dredged up as it traversed across the Martian surface. It actually kind of carved this area. And from there, they were able to find this type of, basically this 90% pure silica. And on Earth, we know that silica it basically happens in these hot springs or near hot steam vents. And we know that these hot steam vents here on Earth were basically where we believe life started. We know that there are, even today, down in the deepest, darkest parts of the ocean, life, just weird signs, this weird extremophiles that live around these hot, steamy vents. We also have signs, again, of volcanism near a place where Spirit was investigating. So we could see the fact that there was ancient volcanism happening on Mars. And we know that while they're very violent, these same conditions help support microbial life here on Earth. So a lot of what these rovers were discovering were that, ancient Mars was very similar and, was a place where microbial life could have formed. We even have signs of flowing water. So near the rim of another place called Gale Crater, you've got Opportunity finding these gypsum rocks where they believe this rock formed where water was flowing through these underground fractures, and the calcium was left behind. You've got also these clay areas, very friendly places for life as well. So, lots and lots of scientific evidence showing that these places were, again, very different from what we see today on Mars. And even craters. So craters tell a great story, and they're able to give scientists a lot of information about the overall geology. And Opportunity studied well over 100 impact craters, something it could have never done if it only lasted the 90 days. And Opportunity being there for more than 14 years really was a great long-term study of the Martian environment. something that up until that point had never happened before. So when we look at Spirit, so this is the one that didn't last as long, here is where it started. There was its landing site, and it was able to travel those 4.8 miles across those 6 years and investigated several things, and ultimately was not able to keep itself powered and warm enough, and it met its demise here at home plate. And then the Opportunity rover, again, landed at Gale Crater, did quite a bit of investigation, and ultimately made it to Endeavour Crater, where lots and lots of great information came back for it in its 14 plus years. Here's one of the very last panoramas that Opportunity took of the Martian surface. And unfortunately, in 2018, we had a really bad dust storm develop on Mars. Here are photographs that Opportunity took across several days, showing the intensification of the sunstorm. So you can see, very bright sun down to the point where, you can barely just make out the dot. And unfortunately, Opportunity was not able to survive that. You can almost think of, unfortunately, this plucky little rover sending its last messages out. It says, my battery's low, I'm getting cold, and it's dark. And unfortunately, after the dust storm, they just weren't able to revive Opportunity. And unfortunately, Mars, it gets very cold. You've got to have electricity, which is developed by its solar panels, to keep it warm. So unfortunately, Opportunity was no longer with us as of 2018. So on we go to the next one. We've got the Mars Reconnaissance Orbiter that is still in operation. You can see some of these amazingly detailed photographs that it's able to pull and provide us compared to one of those first flyby missions. If you remember back in Mariner 6, a very, very fuzzy view. So it's impressive what we're able to do now. And then we'll jump over here to the next one. So then we have the Phoenix lander. That was a polar lander, and it actually found frozen water ice. And that's an actual picture of the ice that it found after it used its scoop. So again, you can actually, now they're finding water, not just, frozen carbon dioxide, but we're actually finding water ice. So Mars absolutely had water at some point. And then we jump to 2011 with the Phobos Grunt, and I'm not even trying to pronounce that. The rest of the particular mission, it was a joint mission between the Chinese and the Russians, and unfortunately, that spacecraft was never able to leave Earth orbit. And then we get to Curiosity, also known as the Mars Science Laboratory. And my computer's jumping around here. So yeah, so there it is, Curiosity, an amazing rover, much bigger than the Spirit and Opportunity rovers. This one did not have solar panels and ran off of basically a special type of deteriorating radiation type nuclear battery. So again, no worry about dust storms and having to stay warm. It's got its own built-in heater, and it is still operating. So here is a view synopsis of the 7 minutes of terror. Where this particular, all the other rovers that had landed before used those basically inflatable kind of shields, if you will, inflatable balls to kind of help them, do a soft landing. This is the first time we actually used this sky crane method where the lander comes in or the rover comes in and it's using several different technologies. You've got uses a parachute, then it's got a back shell with rockets to help slow it down, and then eventually it's lowered down with a crane system, and it is just gently placed on the surface, and then the sky crane and all that other stuff just kind of falls back. So with these pictures, you can see here on August 5th, all the different parts of the Curiosity's landing system, the rover's landing system were documented there. And it is very important where Curiosity was meant to land. So they landed near Gale Crater, which is an impact crater, and there's a mountain that's inside of it that has formed with erosion. So you've got all this material that has eroded over time. So this is a fantastic place to be able to explore the geologic history of Mars. And each one of those layers is a different part of Mars's geological past. And you can just kind of just drive up this mountain, and every time you hit a new layer, you're hitting a new part of Mars's history. And it has been incredibly fruitful in understanding that history of Mars. So here you can see that where we started up here on its landing site, and it has traveled that 15 miles, much more than, let's say, or much faster than the Opportunity and Spirit rovers. But you can see that's its traverse so far. This is as of Sol 3088, which would have put it back to around this past summer, this past spring. I haven't updated this slide. So again, back to Sol 3088. This is the roughly kind of where it started, and now it's on its gentle drive up Mount Sharp. So that's approximately where they believe it would be from this earlier picture. And Curiosity is definitely a bigger rover than the other ones. It's about as tall as an SUV would be, but it's not as long. And I've got a great picture coming up that shows all models, or basically the Earth versions of of the rovers. All three of them, or all three models put together, and so you'll be able to see that. So there it was, Curiosity. Then in 2013, we have India sending its first orbiter, and that is actually still in operation. So that was successful, and it's still being used and communicating. We had Maven, which is another rover. Sorry, take that back. Just another orbiter, and that is still operational. Then we get to ExoMars, and that was a joint mission between the European Union and the Russian Federation. The orbiter was successful. Unfortunately, the lander, not so much. It did crash on Mars. And then in 2018, we have InSight, which is another mission. Again, this is a lander, and it's really helping us understand the evolution and the formation of Mars. So it's using its sensors to determine the sorts of tectonic activity on Mars, and understanding, what are Mars quakes, how often are they, that sort of thing. And then we get to 2020. And there we had some more launches. So you had the Emirates send their first mission. It was called Hope. It was an orbiter, and it is still in operation. We also had Tianwen-1. That was an orbiter, lander, and rover. And I can tell you that the orbiter was successful, and it's operating. The lander was successful, and its rover is still traversing Mars now. So they had great success there. And then, of course, we have the Mars 2020 mission, which then was named Perseverance. That is the rover. And then we have the helicopter called Ingenuity, and we'll talk a little bit about those. But before we do that, I just wanted to show, this is that picture that I referenced not too long ago. You have Sojourner here. That is the size of a microwave. You've got, in this case, you've got the Spirit and Opportunity rovers. They are about the size, I'd say more kind of like a really big shopping cart. And then you've got something, the Perseverance and the Curiosity rovers. They're the size of, again, they're about as tall as an SUV, but not as long. So then we jump to
Mike, again, I was wondering, do you want to take some questions?
Yeah, absolutely. Thank you.
Yeah, we've been having a few. So I'm gonna skip one because I know you're gonna get to that one.
Yeah.
And then we have a question: have any rovers brought rocks back to Earth?
No, unfortunately, that has not happened yet. So that would be a sample return mission. That is a great question because Perseverance actually has that as part of its mission. So it is creating, so all the tests and samples that it does collect, or at least some of them, will be packaged up, and they've actually created these caches. So when in sometime in the future, we launch a sample return mission, the Curiosity stories, the Perseverance rover has already kind of like gotten them set up and cached, ready to be picked up, and they will be returned. Because at the end of the day, if you think about what science can be done, I mean, when we go to a lab with certain specimens or anything from Earth, you've got a big, huge lab that's available here. And if you don't have the equipment, you can send it down the street and say, oh yeah, I don't have a mass spectrometer. So, we're going to go and send it over to, Carrie's lab, and she'll do that. There's only so much you can fit in an SUV. And again, there's a lot of stuff that's taking up. There's hard drives. There's a radioactive battery in there keeping it warm. So there's very little science it can actually do. So so again, there will be a sample mission in the future, but right now, no samples have ever been returned from Mars to Earth.
All right. So we have a question. What would happen to a helium balloon on Mars?
That's a really good question. And I'm not sure I know the exact answer because I don't know how helium would react to things. We do know that the atmospheric pressure is about 1% that of the Earth. So if I think of balloon here on Earth, you've got some pressure pushing on the balloon, and you've got, obviously pressure inside the balloon pushing out. So it has somewhat of an equilibrium state. But without all that, without any kind of outside pressure, I would imagine that if you tried to fill it up, it would be really, pushing very hard on the outside of the balloon. Maybe it would pop very quickly. I don't know. I'm guessing. But there's it probably would sink too, because I would imagine that, the atmosphere is very light. So that helium balloon, even though on Earth it's lighter than air, my guess is that it wouldn't be lighter than the Martian atmosphere. It would sink. But again, I'm guessing.
Still pretty cool.
Yep.
Okay, so what atmosphere density is necessary to sustain surface water, and why did Mars lose its atmosphere?
That's a really good question. I don't know the answer in terms of how much pressure is required to keep things in a water state instead of just immediately evaporating. I don't know that off the top of my head, but what it is believed to be is that why Mars lost so much of its atmosphere relates more to its geologic core. So it is believed that Mars had a metallic core, and it probably was spinning, just like we've seen in other planets, like some of the gas giants. But because Mars was not as large as, let's say, the Earth, it cooled very rapidly compared to Earth. So again, that molten core got cooler faster, which then also dried up or kind of lessened its magnetic field. And without that magnetic field to protect the atmosphere, it just got wiped or basically blasted away over billions of years by the stream of solar particles. So basically, the sun stripped away its atmosphere.
All right, and then the water. And so, how do we know the water isn't from comets?
We don't know that it isn't from comets. So at the moment, there is no understanding of really where the water came from, but we know that water was there. So, and even now, on Earth, I don't know the latest agreement between, I guess folks far more knowledgeable than I am. Even the source of water here on Earth is not fully understood. And it's thought at some point that comets deposited a very good, a large amount of water. So, we don't know where it came from, but we know that it was there, and there have been pictures from these amazing orbiters that we have around Mars that even show that something has been flowing, even within, like, when some of the orbiters come back and re-image a particular spot on Mars, even a few days later, they see something had flowed on Mars. Is that water? Is it something else? Not exactly sure. But again, you've got this, evidence that something is flowing even today on Mars, just not a lot of it. So that's tantalizing just to think about it.
Absolutely. So I've had a question earlier and a question now. So about the names of the of these missions. So do you know why Viking was called Viking, and Perseverance, I think, makes us, we can is yes. more an inspirational name. But why were the Viking missions called Viking? Do you know?
I don't know about the Viking mission, so I'll have to look that up. But I do know like Curiosity, and you've got Opportunity, Spirit, and Perseverance. All those were, I think, call it, crowd suggestions, or basically it was the public that helped name them. And so I know definitely Perseverance. I thought I remembered it, but there were several school-age children throughout the U.S. had suggested that. So it was basically, they were chosen by, it was a public naming campaign.
I like them. And Sean wants to know if we found evidence for life on Mars, evidence of life on Mars.
No conclusive evidence, and even that includes, there were, and again, I don't know the specific, all the detailed findings of the Viking missions, but at one point, they claimed that, yes, we have evidence that there was life according to the tests run by the Viking missions. However, there was now a concern whether or not that, basically the control samples or some other things. So that there was issue with how the tests were run. I don't know all the specifics, but supposedly they were inconclusive. Now, again, you've got people that will say, and this is the conspiracy theorist, no, they said that because people would not be able to handle the fact that there's life there. And again, back in the 70s. So again, I don't know.
And plus, you need to replicate, right?
Yes.
The findings. Well,
exactly. And that's why you need something like a sample return mission and that. So again, one test, you're not going to be able to define anything. So until something goes out and starts walking and crawling across the surface, hard to justify anything. You're right. You need, the scientific method requires us to be able to produce repeatable results.
Awesome. So I think that is good for questions for now, and we'll take another question break in a few minutes. So Absolutely. If you do have questions, keep putting them in the chat. We'll get to them.
Exactly. So Ingenuity, I think, is just an absolutely phenomenal, addition to the Mars 2020 mission, which is what it was called. And this is the first test of powered flight on any other planet. So if we think we're now in, we had successful flight in 2021. It wasn't until in the early 1900s that we even had powered flight here on this planet. So to be able to make that jump in less than 120 years is absolutely amazing. It was built to be light and strong. It was actually tucked up underneath the Perseverance rover, and it kind of stayed all nestled, snugged up underneath during all the landing, the 7 minutes of terror of landing and arriving. So it was quite a bumpy ride, to say the least. And it was, but it was designed to be light and survive very, very harsh terrain and harsh environment. And it only weighs, a little less than 2 kilograms, or about 4 pounds. Yet this little tiny thing is powerful enough to lift off in the very, very thin Mars atmosphere. And again, it's these rotor blades that, spinning around causes lift, but you need atmosphere, you need thick air to actually get that lift. So they're able to basically get this thing to fly in an atmosphere that's less than 1% of Earth's. So it's pretty impressive. And it was designed to fly up to 90 seconds at a clip, and to distances of about 300 meters. And roughly, they don't want to go too high, but roughly about 5 meters off the ground. And when you think about the first powered flight here, in fact, in North Carolina, back in the early 1900s, that was 12 seconds. That was less than the football field too, if I remember correctly. Not that I was there, but you think about, what we're able to do powered flight on another planet for the first time versus what we did here on Earth. So quite an impressive feat.
I have a question.
Yeah.
So does Ingenuity go back to Perseverance to like recharge? No,
Nope.
Nope, she's off on her own.
Off on her own. But it has to communicate with Perseverance to be able to then communicate through the orbiters, through then the deep space network, and communicate back to Earth. So it can't get too far away because it has to communicate through the rover. And that's a good point to this other one. It does fly on its own without manual human control. So it's not like someone is got their little drone controls flying it from Earth, because it literally takes 20 minutes for a signal to go from Earth to Mars. So imagine hitting the up button, and that's going to take 20 minutes to get there, and then 20 minutes back to get this confirmation that it actually went up. So it must be able to be autonomous. Now, obviously, commands are sent from Earth, but pretty much it's got to do everything on its own. And so this is a little bit about the rover itself. So it does have antennas, and these allow it to communicate with the rover, and then on to the orbiters. The blades are very, very light, but if you were to look at a drone here on Earth, the drone rotors are really, really small in comparison to its body. Yet, in this case, these twin blades are much, much bigger, and that's so it can actually, bite into the very, very thin Mars atmosphere. We've got batteries that are charged through its solar panels. And you've got these, very, very strong legs. They tried a whole host of different types of legs, and for the lander. And this is what they thought was the best option. They almost look like golf clubs to me. Got a series of sensors and cameras inside the body. You've got basically the avionics and the brains for it to do its autonomous flight. You've got the solar panels that help charge its battery. And then what I think is just absolutely amazing, and I mentioned, the Wright brothers' first flight, it actually has a very small patch of the skin from the original Wright flyer tucked underneath the solar panel, which is just amazing kind of acknowledgement back to the first powered flight. So here we'll go ahead and get started. So this is a recording of the first flight. So you can see its rotors are spinning up. And so there it goes up for the very first time. Does a little turn. Confirmation that it did, and then it's going to set itself back down. And I think I see in the chat, yes, that is actual video.
So Sean's asking, it's a real video. So this is taken from Perseverance, right?
That is taken from the mast cam of Perseverance back on, oh my gosh, now I can't remember the date, August. Ooh, I'm bad. I should have had put that in the back of my mind. That was last year.
It's so cool, isn't it, y'all?
Yeah. I mean, it's just that, and on Mars, and so what has it achieved so far? So yeah, it was great. So, okay, sorry, it wasn't August, it was April. All right, the month started with A, I was close enough, right? So again, amazing that we could actually have powered flight on another world. And it was able to complete, again, this was all just a technology demonstration, kind of like what, the Sojourner and Pathfinder were back in '97. So it was able to prove, hey, that we can do this only in its first 3 flights. It is actually now in an extended mission called its Operation Demonstration Phase. And so what that's doing right now is just trying to prove, hey, this is how, if we had now better helicopters and we paired them with rovers and for the next series of exploration, this is the kind of things we can do. So it's trying to demonstrate its value. And as of earlier this week, it had 18 successful flights. The total distance flown was 3.8 kilometers, so that's a little more than 2.25 miles, and total flight time more than 32 minutes. So pretty darn impressive that it's able to get that kind of flight time, just charging a battery, and if anyone that knows what it takes to charge batteries, if you're sitting there trying to do that in a very, very cold environment and keep those batteries going, it's pretty darn impressive that, they've been able to actually get this thing to operate. And again, 18 flights. I know, originally they were hoping, we're going to be able to do at least 5. So here you go. And
okay,
in this case,
so this is the shadow. That's what Ken's asking.
Yes.
Oh,
yes.
Okay.
Yes.
Very cool.
So that is it on Ingenuity. So I will kind of open it up for questions and answers.
Yeah, so we have some questions. Let me get to my question document. So Hugo is watching on YouTube and he wants to know, he likes your shuttle, by the way.
Yes,
he's very jealous. Of course he does. And what is the next step on Mars exploration? So what big thing are we doing next and when are we going to see it?
Yes, so that's a really good question. And that is not something I was able to kind of go back and look, only because me personally, I've been so kind of focused on the James Webb Space Telescope and all that's going to do. So I really don't know what the next big missions are. I know that they are planned in terms of Mars exploration, but even now, there's so much focus just on the data we're getting from the host of orbiters that we have, and the fact that now we've got 2 really good-sized rovers with Curiosity and Perseverance that are just going to be able to continue to return amazing data. And allow us to really start pushing the limits of our knowledge. So it's, I wish I knew exactly what's going to happen next in terms of missions, but there is so much just to be able to do with the data that we're getting now.
Right. And that's another thing that that we've discussed is just the actual quantity of data that's coming, not just from Mars, but from all the different missions. It's just years and years and years worth of work to go through it.
And there are only so many grad students that to go around to crunch that data for
so many interns, right?
Yes,
only so many interns.
Yep.
So Kay has a question. Are the polar ice caps on Mars similar to Antarctica?
So not really. A lot of what's in the polar ice caps, it is ice, but it's carbon dioxide ice. So it's made up of different stuff. But in the sense that they're polar regions and they get colder, yes. But they're made up of different stuff. Although we did find water ice up near the poles.
And Stephen wants to know, what's your favorite Mars photo?
I have to say it's got to be the photos back from '97 in the Sojourner phase. So, that again, it's more nostalgia. But if we had to then think about, kind of other photographs, I've always been intrigued when you looked at some of the old orbiters and the photographs they took, and you remember, some people may remember the kind of the big temple or face on Mars, and then when they went back with higher resolution photographs or orbiters, they take that same picture and it's, that's not a face. It was low resolution picture of a mountain in shadows. And that's what it really looks like when you get closer. So there's that one. And then of course, I might have to say my favorite picture of Mars was one that I took with my telescope.
Oh, that's so cool.
it is so, and that's the one thing that's really neat. So we as people of not non-scientists, just people here on Earth with just amateur equipment, we can take a picture of Mars, and when we're able to look at that picture and see, it's like, oh wow, I can see the same sort of features, not anywhere near as closely, but as what they're taking pictures with orbiters, and say, yeah, I can start to understand, and I can see some of what the actual scientists are doing. So it's really cool when you can kind of start to, I won't say replicate, but maybe emulate some of the science.
Oh, that's really cool. So Mom and Dad want to know, if you could run a mission, where would you send a rover or a helicopter, and why?
Oh, okay. If I could run my own mission, it would have to be to one of the icy moons around Saturn or Jupiter. And again, that's assuming that the focus of the mission is to try and find evidence of life. So this is where we've got, in essence, water, huge water worlds, and we'll call them worlds because these moons are huge, and they're warm. They're kept warm by the gravitational interaction of their host planet, where Saturn or Jupiter is just flexing this planet as it orbits, and it's that flexure is causing everything to stay warm in its interior. And it's very tantalizing that got these water worlds are warm inside, covered with sheets of ice. Who's to say there isn't life there? So yeah, I would love to be able to send a probe, an underwater submarine, whatever you want to call it, to one of those water worlds to see what's there. But me personally, I think that again, rovers are great and they're able to do so much science and they're so much more cost effective. But the amount of science that can be done in one day by a human on, let's say, Mars, would be so much more than what you could get out of a year of doing things through rovers and robotics and things like that. So, maybe a human mission to Mars where you can actually dig maybe, 10 feet into the Martian surface and start to excavate stuff and start to see, is there anything hiding underneath there? So.
Very cool. And so the 5 American rovers, have there been any others landed on Mars, or is that it?
Yes, no. So we have the Chinese rover now.
Okay. So there is another rover.
There is
okay.
And
so there's been 6.
Yeah. And then there's Beagle 2, which technically landed. It just never deployed its solar shields or its solar panels. So it's a rover. It kind of really did work and got there. It just couldn't power and communicate.
Yeah. So Stephen wants to know, what would you send to Mars next? We've had flybys, orbiters, landers, rovers, and failed penetrators. So what should we do next? Is it humans?
It is humans. It's humans. Absolutely. So it's the next step. Now, there are other things we have to try and figure out. So it's a long trip. It's a very long trip. And we have 2 data points on how weightlessness affects people. We know that 1G is good. Our bodies love 1G. We know that there are major problems with microgravity, is what we would experience in the trip there and back. But we don't know is what is our body going to do in 1/3 the gravity, which is what Mars is. Because if we send people there, they're going to be there for a long time. They're going to be there for a year plus, because you got to wait for Mars to kind of come back into the right spot so we can launch a rocket to cover the least amount of distance possible. So, it's a long-term trip. 6 to 9 months of it each way is going to be 0 gravity or microgravity, and then a year plus in 1/3 gravity. And that's enough to potentially, maybe even make it. Will someone that's been exposed to that much low gravity, will they be able to come back to Earth and survive? We don't know. We don't have the data. So before we do that, we've got to figure out, kind of is it really just a one-way trip, or can we come back and can we do it safely? So lots of stuff still to prove. Yeah, and that's not even talking about the logistics and the engineering of spaceship and getting all the resources there, and how to protect from radiation. That's just the fact that, we don't know how our bodies will be able to survive just the lack of gravity.
So, and it's just such a long time, right? Yeah.
Yes. Yeah.
So Jessica wants to know, is all communication via radio signal, and is there a better science being developed?
So I don't know about the science being developed, but it is radio signal. But realize radio is just, it's a spectrum in the overall of light. So it's fast. So it is the speed of light. It's just in the radio frequency. It'd be great if we could go to, Star Trek subspace and have instantaneous. But right now, there's just, that's the fastest that we can communicate. What is being worked on is obviously quicker and quicker and quicker methods in terms of more data at the same time. So just like, if you think about where we were with dial-up way back when, and you had a, cheesy 15, K modem, you had to dial back and forth. And then we started getting, some of the, DSL, and then eventually kind of, better cable, and now fiber optics and things like that. Again, the speed was always the same. I mean, even though speed of light is just how much data you can send in one chunk. So that's what they're working on, is can we get, more bits of data through that same, or basically make the pipe bigger. The flow of information will always be capped at the speed of light, but can we do more at once?
Okay, cool. All right, Stephen has a really good question. Mm-hmm. I also have this question.
Yep.
If they find life on Mars, should we leave it alone? Or if they find life, should we leave Mars alone?
Very, very interesting. So I'll have to plug the Fermi talk on, I think it's on Sunday, which is, all about, if there's so many aliens, or if there's supposed to be so many aliens out there, why aren't we, why don't we see them? And that is somewhat answered in that particular talk. But so there is the, potential that will life that we find in Mars, will it be related to us? In other words, is it possible that if you think life is seeded on planets, is it possible that life, this is a real, theory, life started on Mars and eventually got transported and moved to Earth. And we do have evidence of rocks, Martian rocks, through all kinds of, big impacts, things hitting Mars, being thrown into the atmosphere and then flying through space and then eventually landing on Earth, over 1 million years. That we have Martian rocks that have fallen on Earth, and moon rocks that have fallen on Earth, and just again, stuff's out there. So there is this theory that life can be populated from one planet to another. So it'd be interesting. Is it the same? Or if they find life, will it be the same? Will one have seeded the other, or was it completely different? Did it come by completely different means? So good question. I think it's important to study it, but I would agree that you shouldn't, interfere with it. You don't know what it's going to do. Who knows? It's like, as a society, we don't do very well when we try and move one life form into a different environment and vice versa. We have, we think we can do it, but then we end up with invasive species and all this stuff. So that's a really good question. How do you make sure that you are able to study things, but you do it in a safe way where you don't introduce other factors, other problems, things like that. So that's something I think we need to get really good at before we attempt to do anything.
Absolutely. I agree. And that to me is such a conundrum is, you don't want to damage. If there is life, we don't want to damage it, right? I always, personally, we hear about, I guess there's a SpaceX rocket's going to crash onto the moon. And I'm just like, oh, we're such litter bugs, right?
Yes.
We're just, and I know that, they're, I don't think we're anticipating life on the moon, but I'm like, still.
Yeah.
Right. And then what do you do when there is life, and how, do you just pack up and be like, anything we do, it has the potential to harm this. And so we should just go.
Yeah. How do you protect it? I mean,
right. How do you protect it?
God forbid we do something. You look, unfortunately, our history says that the, don't want to say, the explorers / conquerors, what did they do to the environment?
We're not great.
No, we don't have a good track record. No. So,
So, okay.
Very good questions. Yeah.
Yeah, very good questions. And we have one last question. Sean was wondering if we could see your shuttle.
Of course. Of course. So, yes, love this thing. I'm going to stop. Okay.
Oh, yeah. Here, let me spotlight you.
Okay.
There you go. Oh, look at that thing.
I've stopped sharing, right? Okay.
Yep.
So, it's a Lego space shuttle. Absolutely love it. It was really, really fun to build. And it's very, very true to dimensions and everything. You can even has landing gear that will hop in, and you can change the elevators or ailerons or whatever they're called by moving that. And it also comes with a Hubble Space Telescope.
Oh my gosh, look at Hubble.
You can actually pack it up and stick it in the...
that is so cool.
Put it in the...
Sean says, wow, wow, wow.
Yes. So, yes, this was... in fact, all of my Legos have been gifts from family. So.
Oh, that's so fun. And so we have Lego Show and Tell on Sunday. It's our last program of Astronomy Day. So make sure y'all come. And then Stephen has another really good question. Why were we supposed to remember 2,245 days?
Sorry, I totally forgot that. So Spirit. So if we go back to Spirit lasted 30 days shy of Viking 1. Viking 1. So 30 more days and it would have been there longer than, or more, or operational longer than that. So thank you I forgot to bring that back up. Yeah.
All right. Oh, well.
And the point there was one was solar powered, one was nuclear powered. So pretty amazing.
Okay. Very cool.
And by the way, obviously the Spirit was solar powered.
Yes. All right. Well, I'm going to, all right. Well, Mike, thank you so much. What a fantastic, fun program. I think we all love hearing about the exploration of Mars. And I think it's so fascinating to see how many failed missions there were to Mars and how hard it was to figure out how to do this and how unbelievable it is that we've had so many successful missions when it's clearly so hard to do that. So thank you for sharing this with us. And you have another program tomorrow night, right?
No, that's not me. That's another NASA JPL. But yes,
I shouldn't have winged it.
Yeah. No. I think my next one is with
Fermi.
Fermi.
With
Fermi
Doug. Okay, which is also one of my favorite topics to talk about, the search for life, which is super fascinating. Exactly. So thank you so much, Mike. We have amazing Astronomy Days t-shirts and hoodies. So if you want to commemorate this event, go to the store.naturalsciences.org and grab a shirt. You can also go in person. The store's open. And then I just wanted to thank our sponsors and NC Space Grant and Pepsi, and thank our members. So thank you so much, members, for helping us put on programs like Astronomy Days. And if you are not yet a member, please consider joining, because your membership really helps out the museum. And so we will be, we've got 3 more days of Astronomy Days. So all kinds of exciting things going on Friday, Saturday, and Sunday. So thank y'all for hanging out with us tonight, and we will see you tomorrow.
And keep asking great questions. That's the sort of thing that was just amazing, that, we're asking the right questions about what should we be doing. And, again, it's the kind of thought, and as a society, ultimately we get to choose where things go. So
absolutely. And thank you for making complicated topics accessible so all of us can understand. So
my pleasure.
All right. Good night, everyone.
Everybody.